So in this video, we're going to talk about correlation coefficients, also called R values. So when you have a scatter plot, which represents data on a graph, it's helpful to try to fit an equation to that data so we can use the equation to kind of predict for anything in that range. However, and this process is called regression, so we would call this the regression line or the regression equation. It just means fitting a line to the data. When we do this, sometimes it works out better than others. For example, this regression line is like perfect. This one is not so great. Like the data is a little more spread out. This one's also not so great, and this one's like barely doing anything at all because the data's all over the place. So which do you think is the best? It would definitely be this one. There's a mathematical way we describe like how good of a fit is it? Like how strong is that correlation? It's called the correlation coefficient. Coefficient means like a number, and correlation, like we've talked about before, is how are these two variables related. So basically, it measures two things. And also it's called the R value. We usually use the letter R to stand for this. I think that's because correlation, I'm not really sure. Anyway, it measures two things. It measures the strength, so how strong of a correlation is it? It also tells you the direction, so is it positive or negative? It's a number from -1 to 1. So basically, if there is absolutely no correlation, if the data is all over the place, it's an R value of 0. 0 is really bad. 0 means like I can't even figure out where I would put a line through that. The strongest possible relationship is a 1. So basically it's a range of like 0 to 1, and then if it's a negative relationship, you go into the negatives. So -1 to 0. So basically, this is a little confusing, but both -1 and +1 are perfect. It's just that if it's negative, it's got a negative correlation, and if it's positive, it has a positive correlation. So for example, if you had an R value of +1, that means it's perfect. That means it's literally on the line. If you have an R value that's pretty close to 1, like 0.8 or 0.9, that means it's a positive relationship that's pretty strong, but it's not perfect. If you have an R value of like 0.3, that means it's pretty weak, but it's still a positive correlation. But the closer and closer this R value gets to 0, the weaker it is. And again, if it's perfectly 0, then there is no correlation. If it's -1, like I said before, this is also perfect. It's just a negative correlation. If it's close to -1, like -0.7 or -0.8, -0.9, those are all pretty strong, and they're still negative, but not perfect. And then 0.4 is pretty bad because it's closer to 0. So this is a pretty weak negative correlation, and then again 0 is the worst. So for example, here's that kind of all written out if that helps at all. So it measures the trend. It measures like how strong is the correlation and in what direction is it. So which of these do you think would have a correlation coefficient or R value closer to 1? It would probably be this one, because this one is kind of tighter. It's closer to the regression line. This data is still a positive correlation, but it's a little more spread out. Which of these do you think would best represent this data? This data is all over the place. I have no idea even where to draw the line through that, and so it would have an R value of 0. There is no correlation there. And then we can estimate the R value for this stuff. So this one, first of all, should have a positive R value. And it's not perfect, but it's not horrible either. So maybe about like 0.5 or 0.6. It should be a positive number, not quite at 1, but not at 0 either. And this also works for nonlinear stuff. So like if I had this exponential function, it's not perfect, but it's pretty close to being an exponential graph. And so it would probably be positive 0.9 because it's pretty close to 1, but not perfect. All right, I wanted to show you this as well. There's a little app that I put on Google Classroom, and you can play around with, here's the current R value, it's 0.77. That's how good of a fit that data is, but if you drag around this outlier, you can see how like one bad point can make the R value go way down. Or if I make it better, it makes the R value go up. So anyway, it's kind of fun to play.